Over the last few years, I've really struggled to wrap my head around advanced state management patterns in Angular applications. And I've recently started to coalesce around the idea that I'm calling a runtime abstraction. And in the past, I've talked about it in theory, but with this envisioned ScreenFlow proof of concept, I've actually gotten to explore it more of a real-world context. And essentially, this is a prototype in Envision that I can display as this topographical map. And as I click in, I can see hotspots, and then it allows me to navigate around the application, getting both a design sense but also an architectural, information architecture sense of the prototype. And all of this information is managed essentially inside a runtime abstraction internally to this Angular application. So let's take a look at what this means. So first, I want to look at simple store. Simple store is kind of the lowest level portion of the state, which essentially is little more than a behavior subject with some utility methods. So essentially what we do is maintain an internal behavior subject that represents our state, and then we provide access to the current value on that state, as well as providing a method to select properties of that state, and then of course a method to change the properties on that state. And you can see that I'm taking the patch and I'm coalescing it with the current state into a new object, and then I'm emitting that on the behavior subject. So essentially you can think of simple store as a glorified hash that happens to be able to emit values when properties on that hash change. Now this simple store could be Redux, it could be NGRX, it could be some other state management. The point of the runtime abstraction is that the greater application doesn't actually need to know about this choice. So let's go up a level into the runtime abstraction itself. So in this application, I have this ScreenFlow runtime, which happens to be the only feature in the actual application. But again, it's non-trivial enough to, I think, illustrate some of the pros of the runtime abstraction. Now, internally, I'm going to create an instance of that simple store. And while Angular uses a lot of dependency injection, I'm not injecting the store in this case because the store is really a glorified data structure. Again, it's more like a hash that happens to be able to emit values when properties on that hash change. So this isn't something that I want to be able to swap out at runtime. Now, the methods on the runtime abstraction here, the ScreenFlow runtime, I've broken up into two public sections. Command methods, which allow us to mutate the internal state, and then, where are they? Query methods. And essentially the query methods are all just views into portions of that store. Now because the store is actually a behavior subject under the hood, when we select properties off of that store, we're returning RxJS observables of the actual data types. Now, because we're using a behavior subject and we can use distinct until changed under the hood, all of these methods essentially have memoization built into them because they will only change when the underlying value changes, or they only emit a value when the underlying property changes. But the reads are the easy part. Let's look quickly at the commands. The commands are potentially asynchronous. For example, in this one, we're loading data from a remote server. It's going to be an async method that returns a promise. Or they may be synchronous, such as in this version where I'm selecting a hotspot and that either works or it doesn't based on the current state of the runtime abstraction. The nice thing about this is that I'm keeping all of the state management parts in a single place. I don't have to go to another file to look at actions or go to another file to see how side effects take place. The command methods on the runtime abstraction are both the actions and the action creators and the side effects and the state management mutations. So I find this to be super easy to reason about because it's all right here. I don't have to jump around trying to find things throughout the file system. Now let's go up one more layer to see how this runtime abstraction is being consumed in the Angular app. Here is one of the components. I'm only going to look at one, which is the Flovent component, which is essentially this whole component right here. It injects the ScreenFlow runtime and then it has a bunch of static properties. Well, static in that they're not streams, they're actual properties. And what you'll see is that inside my ng on init lifecycle method, I'm essentially collecting a whole bunch of subscriptions. So for example, I'm binding to changes in the route parameters, and then those route parameter changes get piped into the ScreenFlow runtime to affect business logic. I'm also then subscribing to a bunch of properties on the ScreenFlow runtime itself. Now these property subscriptions are super simple. Essentially, I'm waiting for that property to come to fruition, and then I'm just storing it on the current view component. At first, I tried to approach this with the async pipe so that I could move a lot of this logic into the view template. And while that made my view component easier to reason about, maybe, or I don't even know easier to reason about, it made it smaller. What I found is that it made the template itself a lot more complex and harder to understand. And I found the async pipe just noisy, and I had to duplicate a lot of logic. And then if I wanted to remove the duplication, I could have factored out kind of the presentation components and the container components. And it just seemed like I was jumping through a lot of hoops to try and get rid of this kind of code, which actually seemed really easy to reason about once I had it in there. Because ultimately, I'm just collecting properties, and then you'll see in my ng on destroy, I'm simply looping over subscriptions and I'm unsubscribing to them. Because all of the subscriptions in the Angular app use the same interface, I don't have to worry about how I'm collecting these. I just collect them into a single collection, and I unsubscribe on component destruction. So while there's a little bit of a kind of manual labor here, I found that after I got it in place, it was really easy to think about and really easy to maintain, and it also allows me to react to changes on individual properties. So for example, after I select a screen and the related screen images changes, I can take those and then preload them. So I can preload images that I'm about to link to. Now, you might be tempted to think, well, that should be in the runtime abstraction itself, but I would beg to differ. I feel like preloading images is a concern of the web application performance and not of the business logic related to the application. So by keeping this in the web app portion of the application, it allows me to create a cleaner separation of concerns, and I could always get rid of this without having to change the runtime because the runtime doesn't care about such performance concerns. And ultimately, that's all there is. It doesn't exercise every aspect of the needs of a runtime, but I think that it demonstrates merit of the approach and is something that I'm definitely going to continue to explore and experiment with in real applications.